I have with me Scott Semanchik, who is the lead architect at New York Life, and Boris Simonovich, who heads MLOps at New York Life. What we'll cover here today, Scott will start by covering introduction to New York Life, what New York Life stands for, what is the data and AI strategy for New York Life. He'll then cover how they transform their data platform from a legacy one. Boris will then talk about the AI and GenAI platform that they built and how it had a real impact for their claims managers. He will also talk about New York Life and AWS partnership and how it helped them innovate faster. And I'll eventually cap it off by talking about some of the lessons learned and what helps and what doesn't help through this journey. And with that, I'll hand it over to Scott. Scott, over to you.
Good afternoon. I'm Scott Semanchik. I'm the domain architect for the AI and data organization within New York Life. I've been at New York Life about 7.5 years after spending about 25 plus years in the pharmaceutical industry. To give a quick overview of what New York Life is really about, is we're the nation's largest mutual life insurance company. What this actually means is we're beholden to our policy owners, not Wall Street. As Jimmy had mentioned, we are a 179-year-old company that is very resilient and has thrived through both the economic upturns and downturns over the last 179 years. We are embracing technology, data, and AI to deliver exceptional experiences, and we really mean this to both our agents as well as our policy owners. About a year ago, we had the hiring of a chief data and analytics officer, and that really created the AI and data organization. With that, we started down a new data strategy and mission. Our strategy is really to activate the power of New York Life's data through enterprise AI and data products to deliver meaningful business impact. This strategy is built upon 4 pillars. The first pillar is really to scale our data foundational and technology to build our enterprise data products. The second pillar is to elevate data intelligence through AI and analytics. Our third pillar focuses on transforming our culture to where decisions are guided by data. And the final pillar is to empower proactive and personalized experiences for both our agents as well as our policy owners. Now that's where we want to be and where we want to go, but obviously this breakout session is about a modernization effort, so we got to roll back to kind of where we're starting from. We were a Hadoop on-prem data lake environment. We had about 100 different sources coming into our data lake. We did a level of standardization, curation of the data. We used IBM's Big Integrate, which is really data stage for Hadoop, to produce some data warehouses. And then on top of that is where we had Tableau, driving some business analytics and dashboards. The issue is, as that technology aged, we had a lot of different challenges. Our first challenge is we're reaching end of life with, I think it was Hadoop 364 from our vendor. So we had very limited support from our vendor. Then you had Hortonworks and Cloudera merge, and it went from being limited support to a deprecated platform. They basically were all in on their CDP approach and abandoning the legacy Horton stack. At New York Life, we were going through a new compute strategy where we really wanted to lean into the cloud and be a cloud-first company. We also knew on our legacy platform, there were many capabilities that we really needed to improve upon. We did not have ACID capabilities to improve our performance of our data pipelines. And the fact that we had all this data now coming into the lake, we really started to have new requirements about new personas of people who really wanted to access the data so that they could generate better insights. So with that, we had the approach to decide to build a lakehouse architecture using S3 as our data lake and Redshift as our data warehouse. Our path to the cloud was a mixture of re-architecting and re-engineering many components and lifting and shifting some components, and we'll get into those details a little later. But to understand as a department, we couldn't make this journey alone. So we had to explain kind of about how New York Life operates in AWS. So we have an enterprise cloud platform team. They kind of are that bottom layer. If you think of this as a wedding cake, they're at that bottom layer setting out how New York Life operates within AWS. They do all our account creations. They do service control policies for us. They do transit gateway rules, anything along that lines. They also are the process we have to go through to get approved services to be consumable in our environment. Just because AWS releases a new service and it's generally available, that doesn't make it available at New York Life. We have to make sure the right security policies are in place, guardrails are in place to how to use the service. So there's a lot of give and take in working with that cloud enterprise team. And they only focus on services that have a demand pull, right? They're just not going to go and start approving services because the AWS released services. So we had to, in our journey, Glue, Lambda, Redshift, there was a whole series of new services that we needed to get approved for use in New York Life. The second critical team in our journey was our SREs. Now, these are departmental or organization-aligned reliability engineers. These guys are our platform engineers. They run all our infrastructure. They do all our Terraform coding. They're responsible for any cross-account access, all IAM principal development. They are at that platform level that is critical, but it's at the department-wide approach, not the enterprise and not a project-based approach. The third piece of our organization are our organizational engineering teams. These teams are responsible for whether it be data pipeline building, data ingestion, our ETL or ELT to build our domain models in the warehouses. They're doing a lot of that build work. And then the final layer would be our consumers. And our consumers and personas that want to consume data, I think, are growing daily now because of what we have. But it's analytical engineers, data scientists, MLOps, anyone looking to do exploratory data analysis. All of these people have different needs and requirements that are causing us to obviously modernize our platform. At New York Life, we have taken a micro account strategy so that it aligns with AWS's well-architected framework. It isolates business applications because there might be different compliance or security requirements for the different applications. And it establishes boundaries that you must explicitly grant access to the different applications. So it's a very positive, proven, secured approach to ensure the right people are getting access to the right services. As we started down the journey, we then developed a series of architectural best practices and principles. The first one is really to drive everything through our HIPAA ingestion account. All of our data pipeline activities land data in our HIPAA account. Obviously, with life insurance applications, we're dealing with PII, or personally identifiable information. We're dealing with PHI, personal health information. So we really want to be secure about how we handle that data. So we bring it into a HIPAA account, and we don't allow processes or people to reach into that account. All things have to be pushed out of that account, and we'll get more into our pipeline in a little bit. Different roles have different privileges. So the fact that the ingest data acquisition piece that lands the data has the right access to that landing bucket. Things that read it and process it only have read access to that bucket, but write access to other buckets. So we're not having multiple roles or privileges have write access to similar buckets. All clear text PII must be written to our landing bucket, which we'll get into when we go through the architecture. We're driving AWS Lake Formation as our managing of permissions for accessing the data lake for consumers. Redshift external tables will be used so that when users are wanting to access or query the data lake itself, they will be driven through Redshift, and those external tables would be available in that cluster. Handful of other best practices. We want to use serverless capabilities where possible and cost effective. Not always cost effective to be serverless. We have our main Redshift cluster that does a lot of our ETL work and ELT work is a provision cluster because it's running the majority of the time. While consumption clusters go up and down, they tend to lean more towards a serverless approach. We use cross-account access via trust policies. So if we ever would have a breach, we don't have to get in and change IAM access, but we could just sever that trust policy to prevent that cross-account access. And finally, detokenization capabilities are managed through our LDAP group. We'll get into a little bit of the token detoke. We use a tool called Protegrity to tokenize any PII, PHI data. So as it's in our data lake, it's obfuscated, but there is reversible, but you have to have the right permissions, and that's managed through our LDAP that flows into Redshift, and it's Redshift user-defined functions that can handle that particular function. Quick overview of the different accounts we have. As I go through the pipeline work, I'll get into more detail about these. But for the most part, I will talk about all of these accounts except for the MLOps account. Boris is part of the presentation. We'll dig deep into the MLOps architecture and strategy. The initial part of the conversation is what we call our ingestion/data pipeline piece. We're going to focus on our ingestion account, our data lake account, and our data governance account. So as you see from the architecture here, we have a variety of different sources coming into the data lake. Now, we only show SFTP and DMS, but what we actually have are message-based, AWS full replication, DMS, CDC, many different patterns of data coming into our landing bucket. But what we chose to do, instead of building individual ingestion solutions, if you see in the, I'll say middle upper right, you see an Amazon Aurora metadata repository. We built a Glue framework that has patterns to ingest data. So if you're a database migration services full ingestion, loading that database with the right metadata will automatically generate the Glue jobs. So we're not building point-to-point type ingestions, and whether it's a file ingestion, message-based, we drive everything through the framework to get data into that landing bucket. Now, the data in the landing bucket looks exactly like the source system. No transformation at all done to it, nothing taken care of, we're just landing that data. So once again, we have many sources with different patterns coming to the landing bucket. What we did build was one pipeline process. So regardless of how the data gets to the landing bucket, the next set of steps is identical depending on what is in that metadata repository saying what steps are required. So the first thing we do is we do our own delta detection, because if you can't send us the changes, we want to calculate the changes. Because obviously AWS, you pay for compute. If I'm going to continually compute the same data that hasn't changed over and over, not only is my performance of my pipeline going to be slower, my costs are going to be higher. So we try to determine those deltas as far left in this process as possible. We then have a whole series of steps of standardization, whether it is date, time formats, different systems sending us different times, whether it's address standardization, we call out to Address Doctor to standardize all our addresses so they can become joinable later on. And then this is also where we have Protegrity. So this is the Glue Protegrity API call that handles all of that tokenization for PII and PHI fields. And that data gets written to the raw bucket that is still within our ingestion account. So what we have sitting in the raw bucket are only changes standardized and tokenized. We then apply those changes to our data lake. And you see the data lake's in a separate account because that is actually the first layer where end users can come to consume data. We have all type 2 history maintained in the data lake. So if you were a policy owner for 30, 40 years and you moved 4 or 5 times, we're going to have your different addresses with the duration you were at each address. We have converted, we probably have close to 4,000 tables in our lake. When we originally went live and just migrated to the cloud, we had all Parquet. After our analysis, there's probably 12 to 1,400 tables that could benefit from moving to Iceberg. We've converted about 500 tables already to Iceberg, and we're seeing anywhere from a 25 to 40% performance improvement of those tables. So we're about 1/3 of the way done with getting to Iceberg, and we probably have another 700 tables or so to continue. What we found is converting small tables doesn't save you anything, it's not worth it. So it's really those bigger performances on the updates and writes that we want to make sure we convert. And then, that's where we handle Glue, data cataloging, and our lake formation access. You see the data governance account down the bottom. Now, when we went to the cloud and migrated off of Hadoop, it was a 100% structured type data and sources. As Boris is going to lean into later on, we went down a GenAI path where now we're dealing with unstructured data. Well, we were able to use this same architecture of ingesting data, processing it, and moving it to the lake. The difference is we had to add in a little bit of data governance to tag documents for use by the appropriate model. Just because the document's in the lake, it may not be fit for purpose for that particular model. So the owners of those documents tag the documents as appropriate fit for use for the different GenAI models. The second piece of this equation, really now we talk about the consumption side, right? So we're dealing with, you see the transform account, IDMC account, warehouse account, and Tableau. Just for a simple point, most of what I talked about prior to this was re-architecture, re-engineering. The transform account represents lifting and shifting. That is data stage running in the cloud, doing the ETL work to produce our Redshift data warehouse. We're in the process of converting that to IDMC Informatica, which has both ELT and ETL capabilities. Now, I had mentioned earlier about the platform SREs, not the enterprise ones, but our departmental ones. They're the ones who are actually able to make data stage scale horizontally, shut down so we could save money. There was a lot of detailed engineering work that had to go in because it's not a cloud-ready tool. But we wanted to get consumers hitting Redshift sooner, and we didn't want to wait for all the ETL work to be converted. So that's the subtle difference there. That's why you see those two. If I'm back here in 4 months from now, Neil, 4 months, 5 months, transform account will be shut down. 2 months? Perfect. And that's what you see here represented in the architectural picture. Now, you also see a series of Redshift clusters. We have one large provisioned cluster that all of our ETL and ETL runs in that calculates what we call our domain models. The other clusters, many which are serverless, have data shares to read across to them. So whether our data scientists need access to production data to build a model-ready data set, they have a data share in their cluster, but it segregates compute. So they're computing, their models running aren't competing with our ETL and ELT jobs. We have people doing exploratory data analysis. They're in their own cluster. So we just can segregate compute out, but make sure we're using all the same accurate production data. You also see Producer 2.0, which is really, it's an Amazon Aurora database. It is more of an operational data store. It has a lot of our agent information in it. It is updated near real time. It's in the warehouse account because I'm hoping that there will be zero ETL for Postgres Aurora announced sometime during this week because we want to drive the analytics for that data through Redshift as well. So our goal is to be able to make sure, just like we have data sharing, we can make the Producer 2.0 data available into our Redshift clusters so that we can query in one place and see all the data. And then we only show consumption account as Tableau. There are many consumers now who are plugging into our environment. They're coming in through Redshift. We did have to define the external tables in each of those other clusters, although I do know recently AWS released the external tables can be part of the data sharing process. We have not gotten down the path to implement that yet because we were already far down the journey of segregating these serverless clusters and creating the external tables appropriate for them. So how did data enable GenAI? We wanted to use our same data lake structure where we centralize high quality and reliable data for the data scientists. We don't want the data scientists and their GenAI applications to have to go find data, hunt for data, go to different sources, right? We wanted to make sure we could put that data readily available for them. We have the ability to ingest unstructured data. The initial use cases around ingestion is we built our own framework. We're dealing with different sources of data, whether it be Salesforce, Adobe, SharePoint, things like that. So we did build a generic framework that we could use to bring that data in. This improves our data access and scalability, because obviously we have the scalability of AWS and our data lake. And it allows us to have tracking. Data governance and compliance is critical, and I talked about the data governance account. That's really the tagging to make sure we have the right data being used for the right models. And then obviously we have tracking and data provenance. So we have the lineage, just like in our BI reports, we have it from source systems through the lake into our BI reports. Now for the ML and GenAI projects, we have it from source all the way through the GenAI models of what data is being used into what environment. And with that, I will pass it over to Boris, who will give us a deep dive into the MLOps world.
Thanks, Scott. Hello, everyone. Thanks for taking the time to come here. So my name is Boris Simonovich. I lead the MLOps team within New York Life, and that includes everything from using the data to building the models, so ML engineering, to productionizing all the AI solutions and all the platforms that are needed for that. So before I go too much into platforms, I'd like to talk about some of the guiding principles that we used to build our platforms. And keep in mind, we started at square one, so we did not have a platform like this before. And with that, okay. So one of the architectural principles was scalability. So if anyone here has done software development, so this is standard SDLC stuff, we want some kind of provider that can scale any which way we want. So for that, Kubernetes is the obvious choice, and we use DKS. We also needed automation, so we need full CI/CD pipelines from dev all the way to production. Part of MLOps is to productionize absolutely everything we build and automate everything we build. And the reason we want to do that is we need reproducibility. So we want to make sure that any experiment that's run, anything that's built, we can reproduce it beginning to end. Everything needs to be fully versioned. Everything starts at GitHub, it's versioned with Docker, goes into ECR, and so on. And so we are a governed entity. We deal a lot with governance. One of the reasons we want those pipelines to be fully reproducible and automated is to be able to show regulators how we achieved something, how we built a certain model, or how we arrived at a specific solution. For that, we also need monitoring. So again, a lot of these concepts are your standard DevOps principles that have existed for decades. But there's some differences that are required for AI and GenAI solutions. So another principle that we had was modularity. We wanted our infrastructure, our applications, models, LLMs, everything to be modular in a way that we can scale it in any which way we want. So I'll go over that when we go over the operational architecture in a minute. Security. We are used to securing, so having your standard security scans both on code and on Docker containers. But we also wanted to protect our data, so that's some of the stuff that Scott talked about. We also cared about LLM protection. We cared about IP protection and so on. So when we send our data to these LLMs, where does it go, right? So that's kind of an important aspect to consider. And last but not least, and this is something we're still working through today, is democratization. So we are a centralized team. We serve all of New York Life, and we have federated data science teams. We wanted to make sure that all of our data, not just data platforms, but all our data science tools and all of our platforms that host models and host these AI and GenAI solutions are available to everyone in the company. So first we'll start with a very high-level development architecture. On the left, we have the data lake account, which is managed by the data team. That's where the data sets that Scott mentioned reside. That's where all the data comes, whether it's structured or unstructured. We then leveraged SageMaker Studio for exploratory data analysis. So these are the notebooks that data scientists use for experimentation. Our ML engineers use slightly different tooling because they productionize the models. They no longer experiment. And all of that experimentation goes into GitHub. In GitHub, we have ML engineers built templates which wrap up all of the experiment code and Dockerize everything and push it into an ML pipeline. And that pipeline is what gets deployed out to our servers, to EKS. One thing I didn't actually put in this picture in hindsight is SageMaker also has access to Bedrock. So we have all of the, part of what this account has is all of the accesses to the modeling data sets and to Bedrock for these data scientists to experiment. So that's the development world. How do we operationalize it? So again, everything's all versioned, everything's in GitHub. And again, many of these are your standard SDLC principles and pipelines. We have a modular architecture where we have certain technology teams work on the UI. So we have UI teams that build the UI. The AI solutions and GenAI solutions, and by the way, we treat them all as the same. They're all Dockerized. They all have a REST API and so on. So whether we're hosting the model internally, right on our Kubernetes server, or we're using a foundation model, all of the, architecturally speaking, all of the solutions are wrapped in the same exact way. So for GenAI, we had to add a few additional components. We needed an open search database, so a vector database. And we used OpenSearch serverless. And we also needed, I talked a little bit about monitoring earlier, and some of the differences between, let's say, software, regular software where you only need application. We all do infrastructure monitoring, but you also need application performance monitoring. With models, we also need model metrics. We also need to store all the data that the models take in and out, so we can monitor them both for governance reasons and for, for governance and for our own internal operations, so the data scientists can reread, replay, look at the performance of any single model, and be able to improve the product for the next version. So we used DynamoDB for that, and we captured. I mean, we didn't honestly know everything that we were doing. We started fresh. We were learning. We're still learning. Right? It's all a journey. I've been doing this for, well, AI and ML for well over 10 years, and I learn on a daily basis. So with DynamoDB, what we stored was all the prompts, all the completions, all the start times, end times, token lengths, absolutely anything we can get, we stored it all because we didn't know what was going to be important. And our data scientists are who afterwards would review all of this information. We also had access to Bedrock. So from a scaling perspective, Bedrock allowed us to scale in many ways. So that was a really good choice. We had access to many models, and we could spin up our own models, so open source models, or we can use foundation models. So why did we do all of this? I mean, Scott talked about the data journey. I'm talking about the platforms. They're all there to develop solutions for our customers. And when I say our customers, I mean our internal customers, our business partners, and then ultimately something that helps our actual customers and policyholders. So our business partners came to us with a problem. This is a bit over a year ago. And they told us about this claims management experience where they had to generate custom letters that were based on medical records that were extremely complex and had a lot of pain points because they're all manually generated. There's no process to it. It's a very complex problem that AI couldn't previously solve. So all the tooling, everything we built was for that. The problem, and I'll go over the process as well. The problem was that it was highly manual. There was legal exposure because these letters that were built, they're all built by people. People have as many different ways of writing as there are people, right? I mean, it's not like math. We all remember English class where all kinds of papers got different grades and we couldn't really always rectify why. So we wanted to standardize on how we generate all those letters. We wanted to improve the customer experience, or the business partners wanted to improve the customer experience because these letters took a very long time to generate. It was sometimes unclear as to what's in the letter and why it's in the letter. And so we wanted to make sure that everything that's generated is fact-based, is built to a specific standard, and also reduces legal risk. So if somebody writes the wrong word in an email and it can be misconstrued in some way, and let's say a claim is denied, obviously there's a potential for legal risk. So the claims manager experience, the legacy claims manager experience is they review the documents. So these are nurse case manager notes, claims notes, and any other notes that they need to make a decision about a particular medical claim. They will then, after reviewing all those documents, determine whether it's approved or denied. And then comes the painstaking process of laying out all of that data in a logical way and drafting a letter. So this part takes a better part of a day. And this is the least favorite part of anyone who's working on this. So they'd rather be doing something else. So after the letter is drafted, it goes to somebody for review, usually their manager. Letter is reviewed, and then it's sent out to the customer. So we looked at a way to improve this. Now, the nice thing about that is we already had the human in the loop. We already had a review process where a letter doesn't go out because, again, we're a risk-averse organization. We're 179 years old, and we don't want to, as the saying goes, end up on the cover of New York Times. So that was pertinent to the process, and that already existed. So the difference is that we used LLMs for generating those letters. And what took hours turned into seconds. I mean, I wish I can show you the face of one of the claims managers the first time we were experimenting, and they saw something that literally took them half a day, get generated in about 15 seconds. I mean, I thought he was going to take everyone out for drinks that day. So the other thing that was nice about going into this, to the LLM route, is we're able to build consistency. So the models, they're very consistent. They can generate data to, in other words, we can generate prompts which ask for the data to be generated at a certain grade level, let's say, so that everything's readable. Some of these letters are extremely complex, and we don't want lawyers, we don't want you to have a lawyer to be able to understand them. So again, going through this process, we improved the claims manager experience by making the letters, again, through the use of prompts. So our data scientists did all of this prompt work, and when I showed the SageMaker architecture, that's most of what they were doing. There's a lot of that prompting. They obviously also work on the RAG pipelines when it comes to extraction, chunking, all of that other fun stuff. But this is, as far as generation, this is the key. So it increased efficiency, obviously. Everything became automated. And once again, we went from hours to minutes. The prompts also reduced our risk. So one of the things we asked the LLM to do, and it's funny to even use the word ask, because I'm used to telling models what to do. These models, we talk to them as if they're our assistants, right? It's new paradigm. So we asked it to maintain a certain tone. So we want to make sure that models, sound good, for lack of a better word. We want to make sure that customers, especially if it's a negative outcome that they're receiving, that this doesn't add to that. But hopefully it's positive. So we wanted to, again, improve that customer experience, and that came with fact-based generation. Large language models are great at doing that. comprehension level, like I said, we made sure that everything's built at a certain level and good tone. And there were dozens and dozens of instructions. I'm really summarizing them at a very high level. So this obviously helped the customer experience. Additionally, because we're now able to generate letters sooner, faster, more concisely, and to all the other attributes that I mentioned. Yep. So hindsight is 2020. This application admittedly wasn't that hard to build, but it was the first one for us, so there was a huge learning experience. And at the time, it seemed insurmountable. I mean, here's a problem, and it's not your standard algorithmic problem where you can just say, classify this, pull out words here, so like named entity recognition problems or anything like that. You're talking about generation of letters. So we needed to figure out how to break down the problem. And we first started with collaborating on design. We collaborated both with the data team, we collaborated with our business partner, we collaborated with AWS, management, everyone across the organization. We planned a roadmap which included the optimization of our data platform to include unstructured data, so everything that Scott talked about. Also building out our platforms and all the tooling. And for that, we needed executive alignment. For that, we needed the highest level of alignment, which was at the CEO level. And at the time, thankfully, our CEO had a mandate, which was, we want to be one of the best GenAI shops out there. So we worked, and this is what Jimmy's about to talk about. But to me, this is, if I were to summarize the success of this entire thing, this is it, the experience-based acceleration. Again, we didn't really know how to approach the problem. I don't know how many people, actually, by show of hands, how many people have heard of experience-based acceleration? All right, good, so a few of you. So definitely stick around for this part, because this is probably the most important part, at least from my perspective. Oh, sorry, I thought I had that up. So that is what helped us break down the problem, test it in various different ways. AWS brought in experts to help us do all of our testing and to ultimately deliver an excellent solution. So, Jimmy, you want to talk about that?
Yep.
Thank you, everyone.
Boris talked about experience-based acceleration. It's a mechanism that we use at AWS to accelerate delivery. Essentially, what we have seen is the main reason projects either are delayed or fail is because, not because of technology, but because how we as humans work. It's mostly organizational. We don't talk to each other. There are silos within organizations. So we don't collaborate well enough. So this is our way of actually ensuring that our customers are collaborating and innovating the way we innovate at AWS. It's a transformational methodology where we bring in both business stakeholders, developers, decision makers together in a room and just build. It's all about building and making sure that we are taking decisions fast whenever we have a blocker, and we have the right decision makers in the room to do that. So essentially, what it does is it creates that organizational capability to innovate. It also helps, of course, accelerate delivery. And it essentially empowers our builders, because what we have is builders building in the same room with AWS specialists, helping them, looking over their shoulders, and giving them the right guidance. As part of experience-based acceleration, it's a 3 to 6 week effort where the actual building actually happens within 3 days. The first one is building executive alignment, because we need executives to have that buy-in so that their teams are working on this. We define the success criteria, and we identify what we are going to do. As part of the acceleration phase, we define different work streams. We want multiple work streams doing the work in parallel so that we can accelerate the delivery. And then we do the actual 3-day effort. It's usually 3 days, sometimes less. where everyone is in the same room building. Since pandemic, we have been doing it remote as well, and it works either remote or hybrid or in person. Everyone is in the same room, same conference, Zoom call, and building. And we have decision makers, we have escalation methodologies that we use if we need to take decisions. And within those 3 days, we build. What we have seen is this is a highly effective mechanism. With New York Life, we must have done at least minimum a dozen of EBAs. And initially, you will see some resistance because it's a lot of effort. But once we see the fruits of it, once we see how it accelerates your delivery, how it helps you innovate, and how it builds organizational capability, it becomes a way of life. For New York Life, it has now become a way of life. I've heard the cloud team saying that they did an EBA over the weekend to productionalize something. We come to know post that. So for them, it has become a way of life now. And the important thing to note is it's an investment from AWS. It's a no cost where we bring in our specialists and help you innovate. Now, through this journey, from both the data side and the GenAI side, there were a number of lessons learned. We wanted to make sure that you guys take those back with you on what to do, what not to do. Through this journey, what we learned was you should always design for scale. You should always design having a North Star in mind, but build iteratively. You can't do everything once, so you have to take smaller chunks and build, and try to fail fast and essentially pivot if required. You should prioritize architectural reviews. We learned those lessons during the data transformation, but whenever you are, we always have a North Star, but when you are actually implementing smaller portions of that architecture, detailed architecture, make sure you're doing those architectural reviews, going by AWS best practices. Have AWS review your architecture to ensure that you're using the right tools. The foundational models are becoming a commodity. Everyone in the world has access to the same foundational models. What is important is your data. That is what differentiates you from other organizations. So always build a solid data foundation and bring the right models to do the job to your data. Don't take your data to the models. Bring your models to the data. Again, reiterating, it's very important to fail fast. That's how we work at Amazon. We fail fast, pivot, and change. Make sure you are going with speed, taking decisions quickly, failing fast, and if you need to change, you change. I spoke about this earlier, large enterprise organizations have a lot of silos. I've worked with larger enterprises for more than 20 years. I've seen those silos. People don't talk to each other, different departments don't talk to each other. It's only through emails or Teams or Zoom that they talk to each other. We have to break that down. At Amazon, we work in smaller teams where both business stakeholders and technology stakeholders are working together. We call it a two-pizza team. Make sure they're smaller teams delivering specific outcomes. And finally, be firm on the vision. Again, have a North Star in mind. Be firm on that, but be flexible in how you achieve that. Change the course as needed during that journey. I want to eventually end with this quote from one of the biggest innovators in our lifetime. We should always we should never be scared of change. Change is the constant. We are very fortunate to live in this era where we are seeing so much technological innovation, especially with GenAI. Just absorb that, just take that in, and innovate with that, innovate fast with that. Embrace that change and basically build something new, make magic happen. That's it from our side. Please make sure you are doing the review on the app.